This video is going to be focused on converting fractions to decimals and then decimals back into fractions. So in this table below, we have some common fractions that you should probably remember the decimal form of. We're going to show you a few different ways on how you can get them back into their decimal form if you don't remember it, but they are commonly occurring, so we do want to try to memorize them if we can. So you want to just go ahead and fill in some of these ones that aren't filled in yet. So 1/2 is the same as 5/10, or 0.5. 1/3 is the same as 3/10 repeating, so we put a repeat bar over it. So that just means we have 0.33333, and we just continue with threes forever. So if I have 2/3, that's twice as many 0.3 repeating, so I get 0.6 repeating. When we get into 1/4, you can think of 1/4 as 1/4, and so if you equate that into money, 1/4 would be 25 hundredths, or 25 cents if you want to think of it like that. So if I have 3/4, that's just the same as saying I have 75 cents, or 75 hundredths. So that's how I remember think of quarters and money. Okay. So in our fifths, then you can think of breaking a dollar into 5 parts. So if I divide a dollar by 5, I would get 20 cents, or 2/10. So remember, we could always see it as this, or we can see it as just 2/10. Typically this is what you'll see it as, but if you want to remember it like money, that's how 20 cents would look. So if I have 2/5 of a dollar, I would have 40 cents. If I have 3/5 of a dollar, I would have 60 cents. And hopefully you're seeing the pattern that if I had 4/5 of a dollar, I would have 80 cents, or 8/10. So those are all of our fifths. If you would have at the end 5/5, of course that would become one whole. Then we move into the eighths, and the eighths can be a little trickier to remember, but an eighth of something, if I wanted to have a square, and if I divide my square into 4 equal pieces, then I have quarters, right? So I have fourths right there. But then if I go ahead and split this up, each of these are cut in half again. Now I have 1, 2, 3, 4, 5, 6, 7, 8 pieces. So 1/8 of this square is actually just half of a fourth. So if I remember that a quarter was 0.25, half of a quarter would be 0.125, or 125 thousandths. So it's just half of 25 cents, if you can imagine that. So then we have 1/8 as that value. So if I need 3/8, I would be just multiplying this by 3, or it's the same as 375 thousandths. 5/8 would be 625 thousandths, and then when we get up into 7/8, we get 875 thousandths. So those are our eighths, and you can remember them as half of quarters if you want to recall just what 1/8 is, and then keep building from there. When we get into the ninths, there's a nice pattern that we can recognize. So 1/9 is just going to be 1/10 repeating. 2/9 is 2/10 repeating. 3/9 is 3/10 repeating, because that does become 1/3. And then 4/9, if you can recognize that pattern, is just going to be 4/10 repeating. And then finally, when we get into our tenths for our denominator, you can just imagine this again like money. If I'm going to divide a dollar by 10, I would get 10 cents. So if I have 2/10 of a dollar, I would have 20 cents. 3/10 of a dollar, 30 cents. 4/10 of a dollar, I would have 40 cents. And the other nice thing about this is all of these fractions are pronounced as whatever the numerator is over the tenths. And we know that the first number after the decimal is a tenth. So this decimal, 1/10, is pronounced the same way its fraction is pronounced. 2/10 is 2/10. 3/10, 3/10, and 4/10 is equal to 4/10. So knowing the pronunciation of those can also be helpful when you're converting these into decimal form. So these, like we said, are going to be ones that you try to memorize, but if you can't, there's a few ways you can get to it. So if you don't remember a fraction's decimal form, you can either use long division to convert it into a decimal, or you can actually multiply it to get an equivalent fraction that may make it easier to transform. So down below, we're going to try both of those methods. So for 3/4, you might remember that that's 0.75, or 75 hundredths, but there's a few different ways you can get there. So to try the multiply, we could say, well, I want to multiply this by 25 over 25. I'm allowed to do that because 25 divided by 25 is equal to 1. So I'm essentially just multiplying this number by 1, and you're allowed to multiply anything by 1 because it won't change the value of it. When we do that, we get 75 on top, and then 4 times 25 is 100. So right away, we see 75 out of 100, and in your mind, you might be like, oh, well, that's 75 hundredths. And so I know that the decimal form is going to be 75 hundredths like this. So that's one way you can do that. The other way you can do it is by using long division. So our original fraction was 3/4, or 3 divided by 4. So I would just have to say 3 divided by 4, and I'm trying to put 4 into 3. 4 can't go into 3 because it's bigger, so what we have to do is we know we're going to have a decimal number that's less than 1. So I get a point, and then I can add a 0 to my 3. So now I'm really doing 4 into 30. So how many times can 4 go into 30? 4 goes into 30 7 times, and 7 times 4 is 28. And then I draw my line, and I say that I'm subtracting 30 minus 28, and that's a difference of 2. I'm bringing my 4 down again, and 4 can't go into 2, but since we've already added a decimal, I'm allowed to continue adding zeros behind this number. So I can add another 0, and I have 4 into 20 now. Well, 4 can go into 20 5 times. 5 times 4 is 20. When I go to subtract, my difference is 0, which means I'm done, and this is how I can get 0.75 hundredths by long dividing for 3/4. So those are two methods that you can use. The multiplication trick doesn't always work, but for some of these simple ones, you might be able to see easily like a factor that could work for that. So if you wanted to use the multiplication method again for this one, when we're talking about eighths, 12.5 goes into 100 8 times. So if I multiply 12.5 over 12.5 times 7/8, then I would end up getting 87.5 over 100. That one's a little bit harder to see, but it does work for that multiplication trick if you like that trick. The other way you can do it is just by using long division again. So we can say 7/8 would be 7 divided by 8. 8 can't go into 7, so I have to add a decimal point up top for my answer, and that allows me to add a 0 underneath. So I have 8 into 70. Well, 8 can go into 70 8 times, because 8 times 8 is 64. I can subtract, and I get a difference of 6. 8 can't go into 6, but I can bring another 0 down. And then I have to decide how many times can 8 go into 60. Well, 8 can go into 60 7 times. 7 times 8 is 56. We can subtract, and we get a difference of 4. Since we still don't have a difference of 0, we got to keep going. 8 can't go into 40, so I add a 0 back here because I'm allowed to bring a 0 down. So now 8 into 40, that goes into 40 5 times. 5 times 8 is 40. And my difference is finally 0, which means 875 thousandths becomes my answer there. Now finally, in our last example, there's no number here that I can multiply 9 by to make 100. So that means that I have to go with my long division here. So I'm going to say 1 divided by 9. And we know that 9 can't go into 1. So we're going to add a decimal up top, which allows us to put a 0 underneath. So 9 can go into 10 one time. 9 times 1 is 9. I subtract, and I get a difference of 1. Now I have 9 into 1 again. But that doesn't work because we already decided that, so I bring down another 0, and I'm doing 9 into 10 again. So if you notice, we're going to get stuck in this pattern of 9 can go into 10 one time, and then we get a difference of 1 each time. That means that we are going to keep getting a 1 behind our decimal, which tells us that 0.1 repeating is going to be our answer. And if you recall from when we went over the ones up top, all of the ones that had a denominator of 9 were all repeating whatever the numerator number was. So we just have to remember that for the 9s, that those are repeating, and that might save you some of that long division there. So now to go the other way, you can convert decimals back into fractions. There's two types of ways that we can do this. So you have to decide, first of all, whether this decimal is terminating or repeating. So for terminating decimals, that means that they're not repeating. So like those first two examples that we did together up top, where we had 3/4 and then 7/8, those both stopped because we got a remainder of 0. However, that last one where we had the repeat bar was a repeating decimal because we're going to keep getting 1 over and over again. So for terminating decimals, you have to place the number behind the decimal into a fraction with a denominator of a positive power of 10. So what I mean by that is you're going to decide what this is called. So we say this is 4/10, and that might help you start putting it into a fraction right away. But my number behind the decimal is a 4, and I'm going to put it over 10 because it's in the tenths place. I'm 1 place away from the ones place there, so I'm just going to make it 4 over 10. 4 over 10 isn't completely reduced. Those are both divisible by 2, so I can say that that's the same as 2/5. I can't reduce that any further, so 2/5 becomes my most simplified fraction form for 4/10. When I try the next one, I have 25 hundredths because we're in the hundredths place. So 25 hundredths, you might be able to see what we're going to turn that into this time. But we are going to place 25 over a power of 10, and this time we're putting it over 100 because 25 was in the hundredths place. So since it was 2 places after the decimal, I have over 100 here. 25 over 100, those are both divisible by 5. If I divide the top and bottom by 5, I get 5 over 20. But those are both still divisible by 5, so I end up dividing by 5 again, and I get 1 over 4. 1/4 is my most simplified form here, so I get 1/4 as my fraction form for 25 hundredths. Now finally, when I have 125 thousandths, that's going to be over 1,000 because it's 3 places after the decimal. So we have 125. So I can put 125 over 1,000. Those are both divisible by 5. So on top I would get 125 divided by 5 is 25, and 1,000 divided by 5 is 200. Now these are both still divisible by 5, and that gets me 5 over 40 if I divide the top and bottom by 5. And finally, one more time I can divide by 5 again, and I get 1 over 8. So 1/8 becomes my most simplified form of 125 thousandths. So that's how you can do it when you have terminating decimals. They're not repeating, they stopped. We can easily figure out what they are by putting them over a power of 10 based on their place value. But for repeating decimals, it's a little bit different. If you recall on the front page when we saw all of the ones that had a denominator of 9, like 1/9, we said that that was 0.1 repeating. 2/9 we said was going to be 0.2 repeating. So every time you have a repeating decimal, it has to have a denominator of a 9 or something, or 99 or 999, etc., based on how many numbers you have behind the place or behind the decimal. So because I have 4 repeating 4/10 repeating for this decimal, the number behind my decimal is a 4. I'm just going to put it over a 9. Neither of these numbers are divisible by anything else, so this is my most simplest form for 4/10 repeating. When I get into 33 hundredths repeating, I would put 33 over 99 because there was 2 digits after the decimal, so I'm putting 2 9s underneath. Now these are both divisible by 33. 33 divided by 33 is 1, and 99 divided by 33 is 3. So I end up getting 1/3 as my most simplified form here. Finally, in this last one, we have 134 thousandths repeating, but I'm going to put that over 3 9s because I have 3 digits after my decimal. Be able to simplify that any further. So this would be the most simplest form of that fraction that's repeating. So typically, when we're asking you to solve problems like this, you will end up getting ones where you can put it in this nice reduced form. This was just to show you how it would work if you have 3 digits after the decimal for a repeating decimal. Thanks for watching.